Hello, everyone. So I'm Shancong from Industrial System Engineering, and I'm interested in large-scale problems involving like learning and optimization components in those like complex engineering systems with physical constraints. So we have been working on some like engineering applications. For example, the quality control in personal electronic manufacturing processes. And some ongoing work with Samsung on like this HVAC system energy efficient operation, and also like on the like high precision fuselage assembly process. So those are some applications we have been working on, and from those applications, actually, you can see I'm more interested in those kind of like physical system that really engineering system that really have some physical constraint. So we from there we try to develop some algorithms that can deal with those kind of things. The main thing is actually we try to learn this kind of physical system, use a circuit model, and during the learning process, we also try to do the optimization, try to optimize some control parameters, design parameters of this physical system. So for example, some of them can be formulated as a bi-level problem, and some of them are like PD constraint problems, but we kind of treat the PD constraint with a like solve that with a like learning problem, try to build a circuit model map from the control to the state. And then we are interested in how to solve this more efficiently, but also increase the make sure we have some kind of like the accuracy guarantee. So this is what I said. I'm more interested in like learning and optimization problem together to try to enforce this kind of engineering knowledge, like equations, algorithms as a learning problem, and then integrate this into the optimization framework. Make this kind of iterative procedure, because in lots of times, if you want to train a model that is 100% accurate, that can like really predict the engineering system in a 100% accuracy, that's very expensive. So what we really care about is, okay, can we do something along the like optimization trajectory? Make sure your model is accurate along your trajectory. Then hopefully finally you can get a good result, but with less computational effort and also sampling effort, because in lots of the time we need to train it to use the real data. The real data is very expensive. So those are the problems we are recently working on, and so that said, we try to design efficient algorithms that can scale to large-scale problems. For example, especially those high-dimensional design spaces, your design parameter can be high-dimensional, and try to integrate the learning components such as circuit model. But we try to iteratively update the circuit model in AI for science applications. And this semester, actually, I'm teaching a course like physics information learning as like introduction level course to the students. I believe some of the students not only from SYE, also from other departments join my class. I'm looking for collaborations with domain experts who are like in engineering science applications, in general, like the data science, machine learning applications to real world systems. If we want to kind of like integrate the physical system into a kind of design optimization problem more efficiently, but one thing is actually because like in order to deal with this kind of high dimensional design spaces problem, we usually require kind of differentiable structure. So that's why we kind of combine this learning and optimization structure together. And also I'm open to like team on like major grants where my expertise can contribute. Okay. Thanks.
Oh, one. I think the first speaker we had today, Nadia Strobe, she talked about the particle physics experiment and reconstructing events there. I think that can be phrased as an optimization problem, and it's certainly large scale. So it may be an interesting thing that you talk to her.
Thank you. Yeah,
will be an interesting direction to explore.
Yeah, thanks.